All right. Hey everyone, we're going to start the workshop in a second. I'm just going to put a post in the Facebook group just to make sure everyone knows to come. To get on here. All right. I know you're starting a workshop with no one in the group, obviously. Okay, yes. I aim to start at 12:35. Just give 3 minutes or so for people to come on. Okay, and while you're here, you can read the description. I've posted the question we're going over in the description. Okay. Alrighty, Alright, that's okay. I just put the final post. Alright, that's it. That's it. Okay. Oh, good, I can see myself there. Okay, all right. So just quickly, a couple of minutes, just a few notices. I do have to leave early. I did have an emergency I have to run off to, but I did promise a workshop, so I will be doing at least one nasty question on probability from, I think it was the 1993 HSC for 2-unit maths. So it was one of those early 90 papers. So if you do want me to do future workshops, as I said, these do take a lot of time and I'm very busy. I'll need some positive engagement, so I'll need you to smash that like button, give me some nice comments, subscribe and share with your friends. Otherwise I won't have time if there's not enough engagement to do more workshops like this. Other than that, I think it's, let's begin, right? I can't really waste any more time. So the question, I left it in the description. So the question, it's a nice probability one. David has invented a game for one person. He throws 2 ordinary dice repeatedly until the sum of the 2 numbers shown is either 7 or 9. If the sum is 9, David wins. If the number is 7, David loses. If the sum is any other number, he continues to throw until it is 7 or 9. It's a relatively straightforward game. Show the probability that David wins on his first throw of the dice is 1/9. So if we use some notation, probability David wins on the first go. Well, I just said it here. He wins if the sum is 9. So we want the probability the sum is 9. Okay, so this is why I like using notation. But we can break that down even further. So the sum of 9, so we've got 2 dice. Right, remember, dice go from 1 to 6. So we need to find every possible number that adds up to 9. So the first obvious one we can say is 3 and 6. And then what's another possible number? 4 and 5. So those are 2 possible pairs that'll add up to 9. But what we can do is double each because we can reverse the order. So don't forget we can reverse the order because that can be the first die starts with 3 or the second die starts with a 3. So we have to reverse the order. So now what's the probability? So probability of getting a 3 then a 6 on each die is just 1 on 6 times 1 on 6. And same here. 1 on 6 times 1 on 6. And then we can pretty much simplify it in one step. We get 4/36 equals 1/9 as needed. So that was the warm-up question, right? Most of these really hard questions start off with a nice warm-up and then just get worse, like this one does, especially at the end. So part 2, calculate the probability that a second throw is needed. Okay, so second throw. Alright, so they said if the sum is any other number, he continues to throw until it is 7 or 9. So in order for there to be a second throw, he can't win or lose, which means we want the probability of a sum not 7 or 9. Right, we want the probability that it's not 7 or 9, which means it goes from 2 up to 12, excluding 7 or 9. Now because that's a lot of cases, considering how the sum is 2, 3, 4, 5, 6, 8, 10, 11, 12, we're going to use a complement here. So it equals 1 minus the probability of 7 minus probability of 9. Right, that I'm referring to the sum here. Right, because that's much easier to quicker to work out than the individual sums. So when you have a lot of cases to work out, you use the complement to see if there's fewer cases. If the complement has fewer cases, you use it. You want to calculate the case that has less working. So now we need to work out the probability of getting a 7. So we already know the probability of a 9 is 1 on 9, so we can leave that there. So probability of a 7, so what adds up to 7? So it would be 1 and 6 with a 2 in front, because again we can swap it. Then it would be 2 and 5. And then it would be 3 and 4, that's every number. So then it'd be 1, so this is 8 over 9 minus, so these each will have a probability of 1 on 36 of occurring because it's just again this. So that's minus 6 on 36. So again, if we want, I'll just put it over 36 to make it easy. So what's that? 32, it's 26 over 36, so we get 13 over 18. So that's the probability a second throw is needed. Okay. So let's rub off the top of the board. So if you're with me so far, make sure to give us a like below. Let's see what's happening here. Okay, no, the comments are right. So let's just leave the bottom of the board so I have that number for reference. So now it is, what is the probability that David wins on the first, second, or third? So probability wins first, second, or third. Okay. So let's break it up. So probability he wins on the first, right? So that means we want the probability of the first plus probability of the second plus probability of the third, right? Because it's or. Or means we add each case. So probability the first or second or third. Now the probability he wins on the first go is simple, right? Because as I said, it's the probability of getting a 9. What's the probability of getting a 9? Oh, I'll just write it like that. Okay, second. So that means on the first, he can't get 7 or 9. If he gets 7 or 9, the game ends. So there's no need for a second throw, which is what the previous question was talking about. What's the probability that they need a second throw? So we'll use notation, or not 7 or 9, and then it's 9, right? So on the first go, he doesn't get 7 or 9, then he gets a 9. And then the third, so in order for there to be a third game, the first 2 games, no one wins or lose, or he doesn't win or lose. So again, it'll be not 7 or 9, not 7 or 9, 9. So now I just need the probability of each of these, and the question said to leave your answer unsimplified. So what's the probability of a 9? It was a 9th. What's the probability of not 7 or 9? Well, we just worked it out. That was 13 over 18 times. All right, what's the probability of a 9? Okay. Now you should be able to see a pattern occurring. What's the probability of not a 7 or 9? It's that. What's the probability of 7 or 9? It's the same thing. What's the probability of a 9? 1 on 9 again. So if I clean that up a little, this is what we get. So look at that. Unsimplified, you should notice there's a pattern occurring. So this is actually a geometric series. And this is why I picked this question, because a lot of advanced probability questions, especially when you look at the last question, calculate the probability that David wins the game, that is talking about an infinite geometric series, because he wins the game. We don't know how many games it take. It can be technically an infinite number of games before he gets a 9 or 7 to stop the game. So for the last part, the probability he wins, it's just going to be an infinite geometric series. So look at this. That's my first term. And look here, to go from here to here to here, my R is 13 over 18. So then we just use the formula A over 1 minus R for the infinite geometric series. So we get 1 over 9 over 1 minus 13 over 18. And at this point, you can either use a calculator or work it out directly. You get 2 over equals 2/5. So the probability he wins the game is 2/5. All right, as I said, I've got to head off now. But if you enjoyed the workshop and want more, you want 3, you want 4, you want me to do future workshops, I need some good engagement. Make sure to smash that like button. Give me some nice comments. As I said, share with your friends and subscribe. Otherwise, I won't have time to do this. It take a lot of time. I'm very busy. And there's a 3, so I need your support if you want me to keep doing nice free live workshops. Otherwise, I hope you enjoy it, and I'll see you maybe next time.